In this video we have a trigonometric integral to evaluate. If you want to give this a try, go ahead and pause the video. I'll be right back. When evaluating an integral, always try to simplify it if possible. Or maybe you can't see what approach to take. Rewrite it in an equivalent form to see if it makes it more obvious as to what method to use. On this one here, I've got tangent squared of x. I got secant squared of x over cosecant squared of x. Well, secant and cosine are reciprocals. Cosecant and sine are reciprocals. So you can look at this denominator here as 1 over sine, and this secant up here as 1 over cosine. So I can bring the secant squared to the denominator, it becomes a cosine. The cosecant squared to the numerator becomes a sine. So what I've got then is the integral of tangent squared x, and taking the cosecant to the numerator, that becomes a sine of x. Secant squared to the denominator becomes a cosine squared of x. At the square here. So sine squared of x over cosine squared of x, that's just tangent. That's just tangent. So I got that. Basically what I have then is I got tangent squared of x times tangent squared of x. So I can rewrite this as the integral of tangent to the fourth. But I'm going to leave it broken up like this. Instead of tangent to the fourth, I'll leave it tangent squared of x times tangent squared of x. So I can rewrite this then as tangent squared of x. And I have an identity where tangent squared of x is equal to secant squared of x minus 1. In other words, the identity is 1 plus tangent squared of x is equal to secant squared of x. So solving for tangent squared, I get this right here. So I'll rewrite this then as two integrals here. This becomes tangent multiplying through here, tangent squared of x. This will be secant squared of x dx. Then multiplying here, then this gives me a minus the integral of tangent squared of x. So looking at the first integral here, I know that tangent, the derivative of tangent is secant squared. So I can do a u substitution here. U equal to tangent of x. So du, again, derivative of tangent is secant squared of x, and this will be dx. So I'll rewrite this integral then as u is tangent, so this tangent squared x becomes u squared. And then the secant squared dx is du. And this is easy to integrate there. And then for this one here, I have minus the integral. And tangent squared of x, again, I'm going to replace that by secant squared of x minus 1. And then we're pretty much set there. Put this in parentheses. This will be dx here. So this will equal to, so over here in the first integral we integrate with respect to u, so this will be u to the third, add 1 to the 2, becomes a 3, and then divide by 3, so this will be u to the third over 3. But u, remember, was tangent of x. So this will be tangent of x to the third power. I'll put the 3 here, over 3. Now we go to this one here. We want the integral of secant squared x. Well, the derivative of tangent is secant squared. So breaking this up into two integrals, this will just be, because of the minus here, this will be minus tangent of x. And then we got the minus here and a minus 1. That becomes a plus 1. So the integral of 1 with respect to x is x. And then we're pretty much finished. Put the constant of integration here, c. And this is the final answer then for this one. So it'll be tangent to the third of x over 3 minus tangent of x plus the constant of integration. Thanks for watching. We'll see you next time.